let's talk about average rate of change. We're going to find it for the function f of x equals x squared minus 2x plus 1 on the interval from -2 to 3. The formula looks like this. Average rate of change equals f of x2 minus f of x1 divided by x2 minus x1. Think of it as the slope of a secant line, the line that connects 2 points on the graph. So, step 1. We plug in our x values. We've got x1 equals -2 and x2 equals 3. When we plug -2 into the function, f of -2 becomes 9. And when we plug in 3, f of 3 becomes 4. Step 2. We apply the formula. That's 4 minus 9 divided by 3 minus -2. 4 minus 9 gives us -5. 3 minus -2 gives us 5. And -5 divided by 5 gives us -1. That number, -1, is the slope of the secant line between those 2 points. So, what we just did is find the average rate of change over that interval. It tells us how fast the function is changing, on average, from x equals -2 to x equals 3. All right, let's keep going to the next example. This one's a real-life example. We're going to find the average velocity of a moving object. The position of the object at any time t is given by x of t equals 0.2 t squared minus 2t plus 5. And we want the average velocity between t equals 0 and t equals 20 seconds. Remember, average velocity is just the average rate of change of position with respect to time. The formula looks like this. Average velocity equals x of t2 minus x of t1 over t2 minus t1. All right, step 1. Let's plug in the time values into the position function. For t equals 0, x of 0 is 0.2 times 0 squared minus 2 times 0 plus 5. That's just 5 meters. For t equals 20, x of 20 is 0.2 times 20 squared minus 2 times 20 plus 5. That gives us 45 meters. Now step 2. We use the formula. That's 45 minus 5 divided by 20 minus 0. 40 divided by 20 gives us 2. So the average velocity over this time interval is 2 meters per second. And if you look at the graph, this is exactly the slope of the secant line connecting those 2 points.